Hey everyone, in the last video we talked about what Git in GitHub is, Git being a version control software that allows you to take snapshots of your code over time and save them, and GitHub being this like repository of sorts, this sort of box, Dropbox, OneDrive of code that you can have. So it's a really convenient and really nice way to make code available and reproducible, and also a good way of collaborating. So since you're going to be able to, the idea is to have teams in this course. Since the idea is to have teams in this course, we're going to go through how we actually can set up Git and get it set up with GitHub. So hopefully if you're a Windows person, you already downloaded Git or you followed the instructions for Mac. Actually, for a lot of Macs that are recent, you might have Git installed already. So if you haven't, please do install Git. And actually, there is a way that if you are on a Mac, you can go and open the terminal, which I'll go into in a second, if you're not sure how to do that. And you can type in which Git and Git version to see if you have Git installed and where it's installed at, and also the version number that you have. So helpful way of knowing if you are, and if you are wondering about how to open a terminal, probably the easiest way is to do Spotlight search button in the menu bar and type just terminal, and you should see it as the top result. So for a Windows person, you really don't have a good For a Windows person, you don't really have a good alternative besides using the Git bash, which is something that would have installed automatically if you downloaded Git using the link provided and the link shown before. So open up Git bash or open up the terminal, depending on, if you're on a Mac, open up a terminal. And if you're on Windows, open up the Git bash. You can do that by just searching Git bash. What you want to set, and we have the code that's going to be here in this Canvas post where the video is. So what you'll want to do is type in git config. So basically the idea is that you want to set up, you have Git installed, but you don't have it linked to your GitHub account. And so you want to be able to link those together. So git config global, so you're setting the user account for all of your Git and Git folders or Git repositories that you'll be using, and you'll type in username to set the username, and then type in your username. So if you're not sure what your username is, if you go to GitHub, you should be able to, it is anything before repo, and also if you go to your, that is a dashboard. So also if you go and click on the button, it's sometimes on the right side, but if you click on it and you see your username, should be posted at the bottom here. So my username is rfgruner. Use whatever username, obviously, that's appropriate for you, and click enter. And if you wanted to make sure that it's set correctly, you can go and hit up to get the last code and get rid of the username, and that pretty much asks the question, and then it prints off what the username is. The other thing you might want to set right away is the user.email, which for me was my UChicago email address, so use whichever email address you used for setting up your GitHub account, and you're set there as well. So that should be the only time you need to use the terminal or the Git bash in this class. It can be more useful, or there are a little bit more commands that you can use in the Git bash, but this is there are a few more commands and utilities that you can use from the Git bash and the command line. It has more flexibility, but RStudio has a nice Git interface and Git integration into it. So you don't need to use this for this class anymore. So let's close out of that. And so to start using Git in RStudio, First, the easiest way to do this is to go and create a new repository. So if you're on your home page, you can click New, or you can go to your repositories, and there should be another pretty obvious thing that says New. So we talked about repositories a little bit before, and so let's just create one that is a test repo. So you're probably just going to delete this after a while, so you don't really need to worry about it too much. So we're just kind of trying to set GitHub with this. So you can make it public or private if you want. I'm going to initialize this repository with a README just because, and I'm going to create that repository. It'll take a minute, but then you'll come to this page where it says RFGruner test repo, and you can see that there's already a document in this repository. It's a README document. You can click on it and you can actually edit files from GitHub itself. So I'm going to just say, this is some text I wrote in GitHub. And because it's GitHub, if you want to make any changes, you need to, and you want to sort of make sure those changes last, you need to commit the changes. We like commitment here with coding. So you can always go back actually from the committed changes. So let's just say updated README, and I can commit the change. And what you'll see is that now it goes back to the repository. So if I just click on the test repo, you can still see the readme.md, and you can see that there's now some text in this document. What you'll want to do to get it integrated with RStudio so you can do some editing there is click this code button. If you click the code button, it'll ask you to clone. So the idea behind cloning, so to explain that terminology, is right now this repository exists on GitHub, but you want to create a clone of it on a local clone. So this is kind of a repository that exists on a server somewhere, but you want to create a local copy of it on your computer. So let's hit this copy button, or you can just highlight the whole thing, hit Control or Command C. Go to RStudio, and how RStudio integrates with GitHub and version control generally is through projects. So you can go and hit File, Open Project, or New Project, I should say, or you can just click up here. There's a handy little shortcut to it, and click New Project. So what you'll want to do is select version control, because Git is a version control. Again, select Git and paste in that URL, that clone URL from before. You can see that it is going to make this test repository, and it's going to store it. You can choose where you want to store it now. So this is where the working directory is going to be under. It's going to be under this folder in this subdirectory. So you can see I have this in my user account, RFGRU, I have this data folder, and in that data folder I have another folder for Git repositories, and so unsurprisingly this is where I'm going to choose to make my Git repository. A lot of people keep their Git repositories just on their desktop, but you can do it however you want to do it. So then I'm going to just click Create Project, and it's going to take a second, but it's going to switch over to that project now. And what you can see already is that there's a couple of documents in this new folder here, so you can see it put it in this in the folder structure that I mentioned before. And then it created a gitignore document and also an R project. So we'll talk about R project document. So we'll talk about what those are in a second, but I also wanted to point out now you have this handy Git tab as well for interacting with Git. So let's begin by just checking out what the folders are that were created. So if we look at the gitignore, as the name implies, the .gitignore file ignores all the As the name implies, the .gitignore file is a file where you can put in any file that you want Git to ignore. And this is really useful if you have large data, because GitHub is a place to store code. It is not a place to store data, not large data at least. I believe there's a limit of 100 megabytes, and if it's anything greater than 100 megabytes, GitHub will get very angry with you. So the idea, if you do work with large data sets and you want to keep it in the same folders, or you want to keep it in like my test repo, for example, you'd want to ignore it, and then you just want to find a way to have the code download it and put it in that folder, or, you know, if you wanted it to be reproducible, you would put that file that you use as a base file in some sort of other location that you can download from, etc. So let's say I do have a large file. Let's say I have a large file and it's a CSV file, a comma separated file. I can put it in GitHub, the git ignore, and click save. And if I had that file here, so let's create it really quick. I mentioned before that empty cars is a data set that's already exists in R, so you can see that empty cars exists. And what we're going to do now is we're going to just write, this is how you save data in R, so we'll go over this in more detail. There'll be other data camp tutorials to go over this in more detail for sure, but X is going to be the empty cars because it's basically the object that's going to be there, and the file is going to be the name that we want to give it. So I already said I'm going to call this a large file CSV, and normally you don't need to do it. You don't need to put the file in the git ignore first to ignore it, so long as you don't commit the changes if it is a large file. And if you do that, you can see that I have this large file. It's not really a large file, it's actually quite a small file. It's 1.8 kilobytes, but let's ignore that for now. Just say for whatever reason I want Git to ignore it. So now that I have it saved and everything, if I go to Git, and I hit this commit button, you can see all the files that it's going to keep track of, and you notice that the large file.csv isn't there. But if, let's say I want it, it's actually not that big, Git doesn't need to ignore it. Let me save that file and go over to Git and click commit. And now it's going to update and show that you have this large file.csv. So it is going to start keeping track of those changes if I do commit it. It has this the README document from before, and this is some text I wrote in RStudio. And you can save that changes, and if you noticed here, now there was a new thing that was added to this Git pane. It shows that readme.md was updated or modified here. The status of the question mark means that it's untracked, so that means right now that it never was committed, and so Git doesn't know what the file, this would be kind of just starting off, and that's what the question mark are. But M means modified, and you can see that I made this change and saved it. But right now, if I would go to GitHub, and I would refresh the page or something like that, you don't see a change to this README document because I haven't committed the changes and I haven't pushed the changes up to the server yet. And so that is the terminology that is used for GitHub. So I made some changes, and so let's commit those changes. Let me actually just make an R script as well. So, this is an R script, and maybe I could actually write data, empty cars, and then write.csv. I'll just copy this actually from down here to show you how I, wrote this code. Click save, name it something, it automatically tries to save it in the test repo, which is good, and test code. Again, what you'll see is that this was sort of created here, and it didn't and it came up here with the question marks as well. So now I'm ready to make my first commit. The idea is pretty much you want to commit often, as often as you want. There's no downside of committing too often because you can always revert back the changes. So let's click commit, and it gives you to this page. Now you want to probably so you can choose to commit individual files. So you can choose to commit just the git ignore if you wanted to, or just the large files if you wanted to. If you click this stage, if you highlight everything, if you hit Control A and click the stage, it's going to commit all these files, all the changes to these files at once, which for me is fine. There's not really a reason you necessarily need to do one or the other unless you really wanted to keep track of one change versus the other. So you always have to write a commit message. If you try to commit without a commit message, it will say aborting commit due to an empty commit message. This is again trying to help you be the best person that you can be and let you write something. So all you need is one character. I could put a plus and you can create your own notation, but I added some explanatory and exploratory items. You want to be detailed as you can be to kind of like show, so you can revert back more easily. You can see that there's already a revert button here. So now I'm going to commit those changes and click close. And again, if I go back up to this repo up on GitHub, so if I go back to this repo up on GitHub and I hit the refresh button, you see that nothing else has changed. There's no more files or anything. But that's just because I committed the changes. I didn't yet like cement those changes into GitHub by clicking push. So now if I click push, it should ask me, actually, because it's the first time, it should, if you're going to do this for the first time, it should ask you what your username is for the account, just because, or what your username potentially is, but you already set that, but I'm at your password so I can remember that. Because I've been using Git and GitHub before, it didn't ask me that question, but usually there'll be like a little box where you can just enter in your username and or password it might prompt you for. You hit close on that, and now if I were to refresh GitHub, you see now I have a couple more files and everything. If I wanted to add another file, let's say I wanted to edit the README in GitHub, which is not something you typically do, but let's pretend like I had a collaborator and they wanted to edit this file. So let's say collaborator edited this file. Again, I have to commit the changes. Stuff happened. Commit changes. So now I have this change that's up on the repo, but it's not on RStudio, because if I were to, again, sort of just click on the README thing, there's only the old version of this file. So if you are collaborating, it is recommended to pull, and you can just pull by using this sort of down arrow. So that the notation is, you have data on the server, you pull to get it into your local repository so you can make changes to it and everything, and then you can push it back up to the server so that it's saved with push. Again, you want to be committing those changes. That is to say, there's this difference between save and commit, which is somewhat nuanced, but if you save the file, that means you have saved a new version of that file in that location. So if I were to go to the test code, and even if I were to create some, just enter in a couple of spaces and say, print hello, and I click save, What that has done is created this file that is located in this spot on my computer has changed. If I hit commit though, and commit this change, I actually am what Git and GitHub keep track of is the changes, not necessarily the file itself, but the changes that happen to the file. So it notices that this line got deleted, which it kind of didn't get deleted. It just was because I had entered those spaces, and you see that now this file was this line was deleted and was replaced with the same line, and also that I had added this line print hello. So updated file. Now I can commit that change, and it's notice that one file changed. There was 3 insertions and 1 deletion. So that is how Git keeps track of those changes. So it's not quite the same as the whole file. So it keeps track of changes rather than the file itself. I mentioned before, I don't have this updated README document, but I can pull that down. And because I committed afterwards, you usually want to pull before you commit, just in case if someone worked on the same document that you were working on, and you'd have those changes in your document. And usually it tries to do it the best way it can, and so it's almost never will delete any of the information, and it will ask you what sections you want to keep if someone were to have worked on the same document as you. But that's why it's always good to pull first. If you commit it and then push, can be a little bit tricky. Actually, you always want to commit first. Yeah, so if you see, I pull, and now I have this change in my test, in this README document. So that is essentially how you can get Git and GitHub to work with RStudio. Again, you can just push changes up to GitHub, and you're good to go. You can push changes up to GitHub, and